The instructions here are going to say expand. So the problem will look like this. Log base 2, 2 radical 3 over 5. So if it asks you to expand, this is where I'm going to give each piece its own log base 2 word. And then I'm going to apply the product and the quotient property. So I'm going to take the 2 and put a log base 2 with it. The top of this fraction is multiplication. And then I can also do log base 2, radical 3. And then the division is subtraction, log base 2 of 5. But remember what I told you is anytime we see radicals in this chapter, we're going to turn them into fraction exponents. So I need to change this radical 3 into 3 to the 1/3 power. So log base 2. And then also on this one, I'm going to apply that power property, and I'm going to swing that exponent around to the front. And I put a 1/3 there. This should be 1/2. It's a square root. So then now my answer here is going to be log base 2 of 2 plus 1/2 log base 3 of 3 log base 2 of 5. The other thing you need to simplify here is whenever the base of your log is the same as what you're taking the log of, this will simplify to a 1. So 1 plus 1/2 log base 2 of 3 log base 2 of 5. This was in the homework. There weren't a whole lot of homework questions about this. So you do need to simplify this to a 1. The next one, I'm going to do one more expand and then another condense. Yes?
So if it's the same base as the 2 and 2, if it's the same, it cancels to 1.
Yes.
Okay.
All right, let's try another one. So here I'm going to do log base A, and it's x to the 5th, y to the 4th over z squared, all under the cubed root. So now I need to give each piece its own log base A. Again, I'm going to first turn the radical into a fraction exponent. So log base A, x to the 5th, y to the 4th, divided by z squared, and it's all raised to the 1/3 power. The first thing I'm going to do is take care of the power, and I'm going to move it to the front and apply the power property. And it's going to become 1/3, and then it's going to have log A, and then the x to the 5th, y to the 4th, z squared. And now I'm going to deal with the multiplication and the division. So now I have 1/3. I'm going to write a bracket here. So now I'm going to do log A and put it with x to the 5th. The top of the fraction is being multiplied, that x and that y. So I'm going to put a plus sign. And then the division, so it's subtraction, log base A, z squared. And now I have to take care of all those exponents. All of the exponents are going to come around to the front of the word log. So now I have 1/3, 5 log base A of x, 4 log A of y, 2 log A of z. So in the homework, when you checked your answers, this is how they left it. However, when I taught this, I actually distributed the 1/3 to each one. So if you leave it like this, I will give you credit. If you distribute it, that's fine also. So the 1/3 would get distributed to all 3 logs. So log A of x plus 4/3 log A base A of y, 2/3 log A of z. Right. You don't have to do that. You can leave it with the 1/3 in the front. All right, now we're going to do condensing. We had to do this last night in the worksheet before we could solve. So you may have to not only have a question where you're going to condense, where that might be the only instructions, or you might also get a question where you will have to condense first and then solve what remains. So let's try a condense problem now. So condense. This was in the same notes that I just showed you for the graphing. So for this one, I have 1/2 log y, base y, p to the third, q to the fourth, minus 2/3 log base y, p to the fourth, q to the third. Now, I want to condense this, so I only have the word log y written one time. So I'm going to condense it down, and what I'm going to do first is take care of these exponents. This exponent that I normally would have pulled around the front, I'm now going to put back. I'm going to multiply it to the 3 and to the 4. So 1/2 times 3/1 and 1/2 times 4/1. So this would give me a new exponent on the p to be 3/2, and then here 4/2, which would be 2. So now for this one, I have log base y, p to the 3/2 power, and q to the second power. I'm going to do the same thing with the 2/3, swing it around to the front, and I'll get log base y, p to the 8/3, because 2/3 times 4, and then q, 2/3 times 3 is going to give me 2. Now I have to deal with the subtraction sign. The subtraction to me means division. So now I'm only going to write the word log y one time, and then take the p to the 3/2 and the q squared is the top, and then the p 8/3 and q squared. I now need to subtract these exponents. I have some p's that have the same, so I'm going to subtract their exponents to simplify this, and then the q's. Notice q divided by q is 1, or q squared divided by q squared is 1. But for this, for the p's, I need to subtract these. So 3/2 minus 8/3. I need to find a common denominator. It's going to be 6. So this would turn into 9/6, and this would become 16/6. And then now my new simplified log is going to be log base y, p to the negative 7/6 power. And that would be your final answer.
Did you put 1/?
You could simplify it to 1/p to the 7/6 and make the exponent positive, yes. All right.
So did the q just cancel out? Like there's no.
Right, because anything divided by itself is 1.
Okay. But
Or-
you don't put the 1 in here, right?
No, you don't have to, because there's something there.
Okay.
Now, if the p's would have canceled, and maybe, or you could also have put the 1 there on the top if you wanted. And like Devin said, you could write log y and then 1/p to the 7/6 and put the 1 in the top. All right, so last one that I wanted to do for practicing condensing. Do one more. So example 4. Again, it says condense. It has negative 3/4 log base 3, 16p to the 4th, minus 2/3 log base 3, 8p cubed. Okay, so the first thing I'm going to do is put all these exponents back. So log 3, and then this 16p to the 4th, this whole thing is going to get the negative 3/4. And then here, log base 3, and 8p to the 3rd is going to get the negative 2/3. So then now, what we're going to do, and actually this subtraction though, is going to be the division. So this will be a positive 2/3. Yes,
Oh yeah,
that'll be a positive 2/3. Okay, so now I need to go ahead and put it in as a division. So log base 3, write it once. And then in the top, it'll be 16p to the 4th raised to the negative 3/4 over 8p to the third to the 2/3. Now I'm going to distribute this power to everything. So it'll become log base 3, and it'll be 16 to the negative 3/4. I'm going to multiply 4 times 3/4, and this will give me p to the negative 3. And then for the denominator, 8 to the 2/3 power, and then p squared. And now I need to simplify these things. So for here, I could either do change a base, or I could simplify 16. So 16 to the negative 3/4 power. This is really doing 1 over 16 to the 3/4. And then I could do the 4th root of 16, which is 2, and then cube it. So this will actually become 1/8. And then 8 to the 2/3 power. This is really saying the cubed root of 8 and then square it. So that gives me 4. So then now let me go ahead and put these in here. So I now have log base 3, 1/8 over, so 1/8, and then times 4. So that's going to give me 1 over 32. And then I'm going to subtract the p exponents. Negative 3 minus 2 gives me negative 5. So my final answer here is log base 3, 1 over 32, p to the 5th power. Because when I subtracted, I got a negative. So that tells me it's the bottom of the fraction. So you will have to do a condensing and an expanding problem like this on your test. And it will be challenging like this one, where you're going to have an exponent that you're going to have to figure out for the number and for variables. And that is the 2 examples I want, or the 4 examples I wanted to show you for this. Again, make sure your calculators are ready. If you want to practice putting in the logs into your calculator, you can do that. I would show that asymptote so you know, like it's a guideline to show you where your graph is going to go. In here, when I subtracted these p exponents, I got p to the negative 5 power. And whenever I have an exponent that's got that's a negative number, I know to put it underneath a 1 and make the exponent positive. So whenever I subtract and get a negative, I know it's in the denominator.
Okay, thank you.
Yes?
Why was the 2/3 power positive instead of negative?
Because I took that subtraction sign as a division, not as a negative sign. So it was a subtraction sign, and then when I condense, it turns it into division. There was one in the homework, and we did the same thing. They had actually put the negative out front, and I don't know if I did it with this class, but I flipped it around and turned it into a division problem and not treated it as a negative.